A 200-ton steel giant rises above the city, lifting concrete and steel into the clouds as if it were nothing. But here's the paradox. It can't even exist without solving an impossible puzzle first. To build a skyscraper taller than 1,000 feet, you need a crane higher than 1,000 feet. And no ordinary crane on Earth can simply place it there. For decades, that riddle put a ceiling on human ambition. The solution wasn't to build a bigger machine, but a smarter one. A crane that doesn't wait for rescue, but instead climbs the very building it's helping to create. The tower crane is the unsung hero of every skyline, and its story is one of sheer ingenuity. The journey starts long before steel meets the sky. Down in the dirt, a foundation is born, not just a slab of concrete, but a bunker-sized anchor. Engineers dig deep, carving out a pit that feels more like the start of a subway tunnel than a construction site. Into this void, they pour steel and concrete in quantities that boggle the mind. 400 tons of reinforced material, often in a single continuous pour. Once hardened, it becomes an immovable anchor, fused into the ground like bedrock. This isn't overkill, it's survival. Every ton of the crane, every violent gust of wind, every swinging beam of steel, all of it funnels down into that base. A crack, a weak cure, a single miscalculated bolt, and the crane could fail from the ground up. Only when this underground fortress is complete do the first pieces of the mast rise. With the help of massive mobile cranes, workers stack the initial sections, huge latticed steel frames, bolted into the anchor with giant high-tensile bolts. These are torqued with absolute precision, sometimes double-checked by engineers who know one loose bolt could trigger catastrophe. Around the base, inspectors recheck levels and alignments, ensuring the structure stands perfectly true. Because these early sections form the backbone of everything to come, and any flaw here could jeopardize the crane's climb skyward. After days of sweat and meticulous alignment, a short tower stands proud on the site, maybe 50 to 100 feet tall. To an outsider, it looks imposing already, but to the workers, it's just the beginning. Mobile cranes can't go any higher. From this point on, the tower crane must do what seems impossible, lift itself. And this is where the magic begins. Using a device called the climbing frame, the crane grows from within. The climbing frame looks like a massive steel sleeve wrapped around the mast, just below the operator's cab. Inside are hydraulic rams powerful enough to push hundreds of tons of steel upward. The process starts with the crane lifting a new mast section from the ground, 20 feet tall, weighing several tons, and positioning it at the base of the climbing frame. Then with a groaning mechanical push, the hydraulics lift the entire top of the crane. The cab, the long jib, the turntable, the concrete counterweights and all. Imagine 150 tons of steel and machinery slowly jacked 20 feet into the sky. As the crane rises, a gap opens in the frame, and workers, perched high above the city, slide the next mast section into place. Bolts are driven tight, steel groans under strain, and then the hydraulics ease back with a hiss. In an instant, the entire machine settles onto its new footing, 20 feet taller than before. It doesn't stop there. Again and again, this ritual repeats until what began as a short tower transforms into a towering spire. The crane no longer feels like a tool serving the building. It feels like the building itself is serving the crane, giving it the height to rule over everything around it. Inside the cab, the operator rides each climb like a passenger on a machine, lifting itself into the sky. It's not smooth or automatic. It's raw and unnerving. The cab creaks, steel shifts, hydraulics hiss, and for long minutes, the whole world seems to move beneath their feet. One moment, they're level with the unfinished floors, able to see workers welding and pouring concrete beside them. Next, those same floors are shrinking below, swallowed by the climb as the skyline drops away. The higher they rise, the more surreal it becomes, an endless mix of awe, adrenaline, and quiet fear. But height brings danger. Steel doesn't only rise, it sways. At street level, a breeze feels harmless, but at 1,000 feet, that same wind carries the strength of a battering ram, pushing against the crane with thousands of pounds of force. Freestanding, a tower crane can only climb to about 200 or 300 feet before risking collapse. To survive, it must tether itself to the very building it's raising, anchoring with massive steel collars every dozen stories. Yet before each new climb, the top tie-in has to come off, leaving the crane exposed and fragile against the open sky. In those moments, the weather isn't just a detail, it's life or death. That lifeline comes in the form of tie-ins. Every dozen or so floors, workers install massive collars around the crane's mast and bolt them into the building's skeleton. From these collars, angled steel struts bite into reinforced concrete slabs, bracing crane and skyscraper together. It's a partnership. The building gives the crane stability. The crane gives the building its height. But this stability comes with risk. Before each new climb, the top tie-in must be removed, leaving the tower temporarily exposed. During those moments, every eye on site turns to the sky. Weather forecasts aren't casual conversation. They're survival manuals. One unexpected gust, one storm rolling in too soon, and the entire project could be at risk. And yet, when the system works as it usually does, the results are breathtaking. Floor after floor, jump after jump, the crane and building climb side by side until glass and steel brush the clouds. Without this technology, our skylines would still look like they did half a century ago. But even giants don't stay forever. When the skyscraper is complete, the crane faces one final challenge: how to disappear. At this point, it's bolted into the finished roof, hundreds of feet above the ground. No external crane can reach it, so it must take itself apart. The process begins like a slow rewind. The crane uses its own hook to lower mass sections back down, shrinking itself piece by piece. Soon it's nothing more than a stump of steel still anchored to the roof. That's when a smaller rooftop crane, a derrick, enters the stage. Its parts are carried up by elevator, assembled by hand, and used to dismantle the remaining pieces of the main crane. Section by section, the cab, counterweights, and turntable descend to the street below. But now the derrick itself is trapped. The solution? An even smaller derrick is brought up. It dismantles the first, lowering those parts as well. Eventually, the process cascades down to components so light they can be disassembled by hand and carried out in freight elevators. The skyline that once bristled with steel returns to serenity. The crane that birthed the tower dissolves into thin air, leaving only the skyscraper as its legacy. If you're enjoying this deep dive into the machines that make the impossible possible, hit like, subscribe,